All right, let's talk about solving equations. When we talk about solving an equation, basically the root word of equation is equal. You have two expressions that are equal to each other, and you're trying to find the value of x that will make each side equal. Now, sometimes we call that a solution. Sometimes we call it a root, a zero of the function, and when you graph it, it graphs as an x-intercept. If you get more than one solution, like let's say you're solving a quadratic and you get two solutions, then that is your solution set. It's a set of all the values that when you work it into that equation, it would make a true statement. And equivalent equations are two or more equations that have the same solution set. So when you simplify an equation down to a more simple equation, those two would still be equivalent because they would have the same solution set. So let's look at this first example. If we're going to solve to get x by itself, we need to get rid of multiplying by 2 and we need to get rid of adding 3. So we're going to use the inverses to undo that. So the inverse of adding 3 would be subtracting 3. And the inverse of multiplying by 2 would be dividing by 2. So we're going to subtract 3 from both sides, and that leaves us with 2x equals 14. Divide both sides by 2, and that'll leave us with x is equal to 7. Then you can always plug your answer back into an equation to check it to see if your answer is correct. So if we take that 7 and we put it back in the place of x, you can see that the left side is going to equal the right side. All right, let's try another one of those. This one's a little more elaborate. So for this one, to begin, I'm going to distribute on each side to clear those parentheses. Then I want to combine any like terms that I can. So I could combine my constants, -6 and -17. And I could combine my constants 3 and -6. Now I want to get all my variables on one side and all my constants on the other side. So I'm going to add 3x to both sides so that now all my constants are on the left. And then I'm going to add 23 to both sides. So to get x by itself, all I would need to do now is divide by 5. And again, since 6 is a solution, I should be able to plug it back into the equation in the place of x, and I should get the exact same thing on each side, on the left and on the right. Now, we have already been working with rational expressions. A rational expression is just when you have one polynomial divided by another. If you have rational expressions in an equation, then we have a rational equation. Now, if this expression was in an equation, you would not be able for x to be 3. If x was 3, you'd get 0 in the denominator, which is undefined. So before we start that equation, we need to keep in mind that x cannot be equal to 3 as a solution. If we got that as a solution, then it would be something called an extraneous root that we'll deal with later on. So when we look at example number 3, you can see if we look at our denominators that x cannot be equal to 0, because if x was 0, then my whole denominator would be 0. So I'm going to go ahead and just remind myself of that as a stipulation before I begin. So if I were to get 0 as an answer, I would know to exclude that. Now, we learned a magic trick earlier on that is a way that helps you get rid of all of your fractions. If you multiply every term in your equation by your least common denominator, all of your fractions will magically disappear. So least common denominator for 2x, 6, and 3x is going to be 6x. And again, what we're referring to there is if you were going to rewrite each of these equations with a common denominator, it would be 6x. So we're going to go through and we're going to multiply each one of these pieces by 6x. So here you can see in this first set where we're multiplying 6x times 5 over 2x, you can see the 2 and the 3 would the 2 and the 6 would simplify down to 3 over 1. And you can see our x's would drop out. So that would leave us with just 3 times 5, which is 15. All right, now look at this next term. For this next term right here, you can see our 6's are going to drop out, and that would leave us with just x times 5, or 5x. And then if we look at this last set over here, you can see the x's are going to drop out, and 3 simplifies with 6 to give me 2 over 1, so that would just leave me with 2. So again, you can see how much simpler that is when we multiply by the least common denominator. So now we're back to getting x on one side by itself. So I'm going to add 2 to both sides, and that would give me 17. And then I'm going to divide both sides by 5, and that would give me 17/5. Now, I don't really want to go back and plug 17/5 in by hand into that equation. And so instead, what I can do is I can use my graphing calculator to help me with that. So let's look at how we could put that back in to check it. All right, so there's a way that you can tell your calculator what value you want for x. So you can tell it, okay, I want 17/5 stored, so you can see stow is in red down there, so you can see where that is, stored to x. And so now when you hit x on your calculator, it will have that value stored to x. All right. So if we take what we had on the left-hand side of our equation, so what we had on the left-hand side of our equation was 5 over 2x. So I can, if you're not familiar with how we get that little fraction builder, it is alpha y equals, and so we would have 5 over 2x, and you can see that gives us this value. All right, then on the other side of our equation, we had 5/6 minus 1 over 3x. So let's do that. So again, alpha y equals 5/6, and then minus, and we'll do that same alpha y equals 1 over 3x. And then you can see we get that exact same value. So if we got the same thing on the left as we did on the right, then we would know that our equation was equal. So that's how we can check this on our calculator, is again, to review, what we did was we stored that value to x, and then we put in the left-hand side of the equation, which was 5 over 2x, and our calculator is plugging in this 17/5 in the place of x to get this value. Then we took what was in the right-hand side of the equation, and we type that into our calculator, and again, it's using this value for x. And so you can see that our left-hand side and our right-hand side are equal to each other. So it's just like before when we were plugging it in by hand and we were making sure that we got a true statement, that both sides gave us the same value. As a matter of fact, sometimes they'll actually ask us the equation in that way. They'll say, hey, if this is y1 and this is y2, then solve for where they're equal to each other. So here's an example of that. They might tell me this is y1 and this is y2. Find all the places where they're equal to each other. So all I'm going to do is just set those two equations equal to each other. All right, so again, let's use that magic trick where we can make all of the fractions go away by multiplying by the least common denominator. So we have x plus 4 to the first, x minus 4 to the first, x plus 4 to the first, x minus 4 to the first. So our least common denominator will be x plus 4, x minus 4. All right, so we're going to multiply every single term in the equation by that x plus 4, x minus 4. So if you look at this first term right here, you can see the x plus 4's drop out, and that just leaves us with x minus 4. If you look at this second term right here, you can see the x minus 4's drop out, and that leaves us with 1 times x plus 4. And then in this last term, you can see that the entire denominator and the entire numerator drop out, and that just leaves us with the 22. So if we combine there, we're going to have x plus x is 2x, and the positive 4 and negative 4 drop out, and then divide both sides by 2 to get x by itself, and x is equal to 11. The only value that x could not have been in this problem was negative 4 or positive 4, because that would give me 0 in the denominator. So 11 is perfectly fine, and you could plug it back in and check. Now, a couple of different types of equations that you might encounter. The first is an identity, where you have the exact same thing on one side as you do to the other. You'll notice that 2 plus 1 is 3, x plus 3 is equal to x plus 3. Basically, you could plug any x value in, and it would make these two sides equal to each other. Inconsistent, however, is when there's no way for that left side to equal the right side. You could put any number in that you want to, and there's no way that these two sides are going to be equal to each other. That's inconsistent. What we have worked with today is conditional, where we had an equation that was not an identity. It wasn't true for every value, but we were able to find a solution where it was true for at least one value. So that's what each of the examples were that we had today.